there are cases where you deal with things that aren't math, like divisions by zero, but they're totally perfectly defined. Um, right? So, like, an example is when you're trying to find the angle whose tangent is anything over zero, right? So, like, uh, 2 over 0. Sure, why not? Let's do that. I can name an infinite number of angles whose tangent is this. Because what this is this is dy. This is dx, right? This is a slope. So we can have angles. So here's our x-axis. Here's our y-axis. Here's our origin. So our angles can go, from here, right? To have a slope like this, you need to be vertical. So you can be here, between the origin and some point on the y-axis, on the positive y-axis, and that'll give you something like this. So say this is 2. Or if it's like this, well, now it's this guy, for sure. And I don't have to evaluate this. It would be retarded to try to. So this angle here, this angle is going to be pi on 2. And this angle is going to be 3 pi on 2. Or those plus or minus any number, any whole number multiplied by 2 pi. Thus, there's an infinite number of them. So here we did math without doing math, without computing this. We don't want to compute this because we can't compute this because this is nonsense. This is not going to produce anything. Division by zeros doesn't cooperate. But the context of the situation makes everything work just fine. It's annoying when you're programming and you have to make these special cases. You have to write in checks to make sure that the dx is not 0. And if it is 0, check the sign of dy. And then you can figure out what the angle is. I've written that code many, many times. It's obnoxious, and it would be nice if I didn't have to do that, but yeah. I'm not clever enough to figure out another way. But yeah, evaluating it is a problem. Because if you ask the computer to just evaluate this, it's going to throw an error, and you're going to get garbage.